In this video, we're going to look at the mechanics of Chapter 1. By mechanics, we mean some of the basic calculations and problem solving that we will do using the concepts that we learned in our last video. The first example we'll look at is one related to the scientific method. You'll recall the scientific method follows the flow chart shown here. We make observations. We develop some hypothesis about why these observations are the way they are. We come up with an experiment to test that hypothesis. If the experiment is consistent with the hypothesis, we develop a model that will more generally explain this, and then we use further experiments to test this. And a classic case we can look at is that of acid rain. Acid rain may be familiar to many of you. It's lower pH precipitation, particularly in the Northeast and the eastern regions of the United States, where precipitation drops down to low levels, and that precipitation can have damaging effects on structures and on wildlife. The observation is low pH rainwater. You don't necessarily observe that in, for example, Arizona or New Mexico. So typically, pure rainwater in out over the ocean will have a pH of 5.6 approximately. And it was observed that there was significantly lower pH rainwater occurring up in the Northeast. And this particularly was in regions where they were burning coal in coal-fired power plants. And it was hypothesized that it was the sulfur in the coal that was causing the acid rain. Now, it turns out for environmental science, it's very difficult to do experiments because you're doing things on a very large scale. But effectively, an experiment was done. They added what were called scrubbers to the smokestacks on coal-fired power plants. Those scrubbers simply removed the sulfur from the exhaust streams. And it was observed that the pH rebounded. The pH, instead of being low, it bounced back up again. So the basic model, which was a nice robust model to start off with, sulfur in the coal gets oxidized to sulfur dioxide and sulfur trioxide, which then goes into the atmosphere, and this dissolves in rainwater to make sulfurous and sulfuric acid, giving acid precipitation. And sulfur dioxide and sulfur trioxide are much stronger acids than carbon dioxide. Now, it turns out that over time, the pH changes weren't fully achieved. And so there were further experiments, and it was observed that, nitrogen emissions also can contribute to acid precipitation. So that was a further step in the scientific process. So that was kind of our last step, further experimentation to challenge our model. And while it turns out it is true that sulfur dioxide and sulfur trioxide do contribute to acid rain, they're not the only contributors. The next topic we're going to look at is significant figures. So to remind ourselves, we had this concept of a numerical value that we would see from an experiment. Maybe in lab you'll do a measurement. How many digits do you write down? Do you write down all the numbers that are in your calculator? Well, your calculators will generally have anywhere from 10 to 20 digits, and usually most of those digits are information empty. They have nothing to do with reality. They're effectively random numbers. So we want to know, when we look at a number, what values tell us something. So we need to be able to know how many significant figures we have in a numerical value. So here's a table. And at this point, you should pause the video and look at each one of these values and tell yourself how many significant figures are associated with each of those numbers. And then once you turn the video back on, we'll move on to the correct answers. Here we see the correct answers. So for the numerical value 0.0035, there are two significant figures. The 0 between the decimal place and the 3 have to be there to indicate the magnitude of the number. But if we wrote it in scientific notation, it would simply be 3.5 times 10 to the minus 3. So those zeros are only placeholders. Now the next numerical value is 3,500 with a decimal place. That decimal place indicates that everything to the left of the decimal is significant. And so in this case, there are 4 significant figures. Next up, the number 35. Two numbers, even without a decimal place, they're both significant. We have 2 significant figures. Now, if we want to indicate 3,500 with 3 significant figures, we need to write it as follows. 3.50 times 10 to the third. That would have 3 significant figures. The next number, 0.00250, has 3 significant figures. The first 0, of course, has no significance. It's just sitting there. But the 0.00, those are placeholders. The 2 and the 5, and then the following 0 all contain information. There's 3 significant figures there. The 250 at the end. 56.20 has 4 significant figures. 305.10 has 5 significant figures. Finally, we discussed mathematical operations, and if we do multiplication, division, addition, subtraction, how do our uncertainties or our number of significant figures propagate through to the final answers? And so we have some examples here to illustrate this. We have 32.40 times 0.082 and 22.4 plus 0.010 and 9.45 divided by 93.75. Do all 3 of these calculations and then pause the video now, do the calculations, and determine how many significant figures are in the final answer. Write your number down with the correct number of significant figures. Moving on to the answers. We see in the first case, this is a multiplication. 32.4 has 3 significant figures. 0.082 contains 2 significant figures, the 8 and the 2. If we multiply these numbers out, we get an answer that needs to have 2 significant figures, that is 2.7. Next, we have 22.40 plus 0.010. 22.40 has 4 significant figures, 0.010 has 2 significant figures, but if we line these numbers up when we add them, 22.40 has precision only in the hundredths place. 0.010 has precision all the way to the thousandths place. So our answer is limited by the least precise placeholder, that is the hundredths place. So our answer has precision to the hundredths place. And if we add these 2 numbers together, we get 22.41. The precision is in the hundredths place. And you can see that even though we added on one number with 4 significant figures and one number with 2 significant figures, our answer has 4 significant figures, is determined in addition and subtraction by the least precise placeholder. Next, 9.45 divided by 93.75. It's a division. 3 number precision divided by 4 significant figure precision. The answer will have to have 3. And so 0.101 is our answer. Next, we'll move on to Chapter 2 and begin our study of chemistry.